Now let's take an example just to make it, to put it into a particular context. So let's assume an organization develops software for life-critical systems. The diagram there is some sort of a medical system, and that could be pretty life-critical, mainly from a monitoring context more than anything else. Now, there are many competitors, so project cost overruns are to be avoided, okay? We can't afford to just spend money all over the place. Regulatory compliance is extensive in medical software systems, is pretty rigorous. Developed products are novel, a little innovative, but they're not experimental. We're not doing experiments. That's prototype. That's a different matter. So we're actually producing software for life-critical medical systems. So what are we going to do? Now, this context, show you what it means. Life-critical systems require extensive testing to prove they do no harm. All medical systems first do no harm. And they fail safe. Now, software systems drive safety people nuts, because with software systems and software generally, it's pretty hard to predict exactly how they're going to fail. You can't guarantee it's going to fail in a safe state, and that's a problem. So we need to be able to say, well, yes, it's critical, and it will fail safe. All right? So there need to be extensive standard tests of all levels of development, from unit test to integration test to system test. Avoiding cost overruns requires accurate costing. So requirements management and estimation become very important. All right? So no gold plating. We can't stick in requirements just because we like it. We can't interpret a requirement more than what's specified. It has to be reasonably well controlled. Otherwise, we're going to get cost overruns. Extensive regulatory compliance. Usually configure the development tools and the environment to record regulatory data just as a byproduct of doing things, which is about the cheapest way of doing it. It's very hard and very expensive to go and manually seek all this information afterwards to record it. So the more regulatory information you can gather just as a byproduct of doing things, the better. So we manage the risk of novelty by developing the risky backlog items first. Okay, so that's what we do. In this development, let's say we're doing a typical sprint. We've done all the sprint 0, so we've done most of the planning, and we're into the sprints. Okay, first thing we do, review the backlog items. We expand and clarify the items, so we get down to just exactly what this is going to mean. We re-estimate the sprint backlog, and we review the sprint itself. Okay, before we start going, we have a look and say, have we got everything? Did we miss something? Have we got some dependencies between backlog items that we haven't discovered? We might then revise the system design. I would hope you would. And we implement the backlog items, and then we do a system test. All right, so that's going to be a very typical sprint for an agile development. So let's have a look. Review the backlog. The new backlog item may have been added, so we now need to reorder the sequence of them all. Priorities may have changed. Again, we need to reorder them. We need to review the dependencies between backlog items. Maybe we've discovered one, and we need to put that in. All right. Now we select enough backlog items to make up the next sprint, approximately, right? Because we haven't done a full estimate yet. We're simply picking them all out. So if we have the capacity to do, 40 units in a sprint, then we'll pick about 40 units of backlog to do. The quality assurance of this, the early sprints usually involve more infrastructure. So just be on the lookout for that in the early sprints, if people are diving in to implement some esoteric piece of functionality, they're probably doing what most developers are doing and getting stuck into the interesting stuff and forgetting that you actually have to plan the infrastructure and do that properly. Undiscovered tendencies make life difficult, so review them thoroughly in the first few sprints. All right? Now, do the sprints, or does the planned sprint now reflect the latest sprint velocity measure? Are you somehow trying to put 10 pound in a 5 pound bag? Are you trying to put 60 sprint units into a 40-unit sprint. That's a recipe for disaster, because it just means that everybody's going to be working overtime and rushing things through. So let's get realistic. You may have put all these things on the backlog or in the sprint. Now you've done your estimates, now it's time to review that and take out what you can't manage to do in the sprint. Right, now we're in the sprint, so we'll clarify the requirements. And the usual phrase there is that you've done something and say, oh, is that what you meant? Oh, didn't realize that. Now, it's kind of nice to do that before you spend all the money going and developing things. So test your understanding with the story of the implemented requirement. And people are getting around more and more to this. The user won't be able to tell you what the system ought to do. They'll tell you what that is internally. Won't tell you what you should do. They'll tell you what the system ought to be able to do. And so a lot of people are coming around to this, the user stories that tell a story from the user's point of view with the system as a black box. You know, I deal with the system, I want the system to do this, I'll do this, and I expect it to respond that way. Now that's pretty good. The format, the template format of that is, as a role, type of user, I want to achieve some outcome in order to do something else, right? So usage scenario, which describes a real-world example of how one or more people would interact with the system. That's a bit different from a user story. A user story is a small, simple thing from the point of view of one person. A usage scenario is a bigger scenario about how the system would behave interacting with multiple people. So that's one way of doing it, and you can check the story with the user that way. A different way is to develop a test of the requirements. And these can be quite illuminating. You go to the user and say, look, if the system did this and satisfied this test, would that be okay? And you'll usually get some answer about, oh, no. And that's great. Now, one of the problems with developing tests is that we frequently develop the happy case test, the test of does it work? All right. What you should be doing is developing happy case tests that it works, tests where it should not work or should not do something, okay? And we want some boundary case tests. What are we going to do on the edge of things? If you need a great deal of rigor, you need a great deal more perspectives and more tests. If you're not too concerned about the rigor, then you need less tests. Estimation. Estimation is a very contentious activity. There was a meetup group I was attending for a couple of years, and it got so bad eventually they simply banned estimation as a topic of conversation. It just went round and round and round. There was no agreement about it. So there are numerous ways you can do your estimation, and yours is probably as good as anyone else's. But these are estimates, not predictions, okay? They need to be good estimates and rigorous estimates, but they're still estimates. Estimates improve with more complete understanding of the problem. So you can use planning poker, you can use a detailed work breakdown structure, you can use function point estimates, which is another way of doing things. You can use a historical comparison, which is pretty good. Or you could use some sort of parametric estimation such as Kokomo. And Kokomo works pretty well, but I found when I looked into Kokomo, it really was a very rigorous method of coming up with an actual number. But at the heart of it, when you got down to how big is the software, the answer was guess. I thought, oh, I hope you're guessing well. So anyway, there are different ways you can do your estimation, and whatever works for you, whatever you feel comfortable with and is acceptably accurate. Now, revise the system design. Some parts will be new, some will be revisions to existing designs. And what you need to do is how are you going to know that what you revised will actually work? Your revised system will work, okay? So obviously we understand we have to produce a working design. But part of the QA is reviewing that design to make sure we haven't broken it and it actually will continue to function. So there are no widely accepted methods of design evaluation. Now the reason I know this is that I was close to development of a standard for software architecture documentation. And one of the questions that came up is that we really needed a standard on architecture evaluation, and of course there wasn't one. There are various attempts, but there's not a standard one. So if you're going to review the architecture, again, peer review by experts is the least you can do. An ATAM analysis or a CBAM analysis, that is some sort of a scenario-based analysis of the architecture, would work reasonably well. A HAZOP analysis is also a scenario-based analysis, but it's a very detailed and very rigorous analysis of the design. And the comment there, any review is better than no review. We are terribly prone to skipping over the reviews. Now, sprint activities themselves. Now we're going to implement the backlog item, so, and then a miracle happens. Then we do some coding. Now I won't bother to go through the coding, except to argue that you really ought to use fairly strict version control on this medical software system. If you look at the standards for compliance for standards that that medical software is required to comply to, their main concern is the effect of modifications in the system, because they found that it's modifications that cause most of the trouble. The initial development will probably be pretty good and will pass all the various tests, but it's the modifications that introduce subtle bugs. So they're very concerned about that. As a consequence, they're very, very concerned about configuration management and tracking the changes. However, you might be developing something new, and my personal recommendation is automated testing is brilliant. Automated testing for all the way through. Unit test, integration test, system test is very much a must. And you should configure all your tools to log all useful information and throw it off. Information that comes as part of the implementation process and not something that's extra. The more you can do that, the better, because that's basically free data. Now, you should measure what's important, right? And you should decide what's important. Now, there are changing views of what you should measure about software. Now, these come about because we're gathering better knowledge about the relationships between measures and causes, and measures as indicators of the state of the software. One that I was fairly impressed with recently was that a reasonably good measure, it's actually a collection of measures, of software maintainability. And this was achieved through an automated measure, and it worked very well. More and more people are coming up with more automated measures of software, and so I'd recommend you have a look at them. The two reasons is faster, is cheaper, and is more accurate than people. Testing coverage usually is a pretty important measure. Sprint velocity is usually also an important measure in software development, and the burn down rate is a pretty important measure as well. Now you could measure other things for different reasons, but some measures, you should decide what it is you're going to measure and what you're going to do with those measures. Now, a summary of all that is sprints are a process, but the activities in those sprints are not regular. They're not necessarily repeated. They can vary depending on what you have to do. But there is the same challenge. How will you know that you've done what was intended? And how will you know each sprint activity achieves what it should? So, have you produced the right thing? And is the thing itself of acceptable quality? Agile development does rely on the professionalism of the developers, and Agile QA relies on the same professionalism in the QA personnel.